Good day, everybody, and welcome to Geogebra 4 lecture. Okay, and today I will tell you about two very important things. So, one is uh, how to sketch or plot function over a range over a range and how to plot uh, piecewise functions, piecewise function, primarily these two, then something more I will also do. So let us go here and we start our uh, GeoGebra, and it is like this. See, when you plot a function like say sin x, you sketch, the function is sketched or plotted from x minus infinity to plus infinity, like that it is sketching the function. Clear? But suppose I am interested to sketch the function only between 0 to 5, and for x less than 0 nothing, for x greater than 5 nothing, in between. So only this portion I want to sketch. Got the point? So I this is what is known as plot function over a range. So what will be the syntax of that? How to get that? The syntax of this is very simple and very logical. You then specify that if the range you specify, if x is suppose greater than minus 2 and less than 4, the function is sin x. Is it? So if x lies between this, the function you want to plot is sin x. Otherwise, in other ranges, the function is not there. Something like that you want to do. So exactly that what I will do now. So so it is there. So go to my here, and then I say that this I will now edit, and I will write if capitalize small f, this is all first brackets, within that it will come, and you say that if x exists, that is minus 2, what I wrote, x less than 4, then you put a comma and write down the function. So this will be sin x, just like that. Then let us see whether it does something. Yes, it does. So the function f has been plotted, this object, and it is within this range, minus 2 to 4. And it is true for any other functions. I can do this kind of segment of a particular function. We have seen how to draw a segment of a line. Similarly, we can always draw the segment of a graph. Clear? And you can also say write another, to give you another example, that suppose you say say if this if is very interesting command. If x is between -6 less than x, and if it rise between this to 0, this range, then the function is comma c x. You simply write, it will be a straight line. So -6 x will lie between -6, x is greater than -6, less than 0, then the function is x. If you do like that, it will sketch the function this way. See, -6 to 0, it is a straight line. And you can draw any function for that matter over a particular range. That is, in other words, what I am telling, that you can you may be interested not over the whole function but over a particular range, what is the values of the function. Then this statement is really very handy. Okay, it shows the range here. I typed in a different way if it does not show, but this thing has been translated into this nice form by Geogebra. You don't worry about that. So this is very interesting. So this is how it can be done. Okay. Now I will now tell you how to sketch what is called the a piecewise function. Okay, for this is also very useful sometimes. You come here, and here what I say is this one. This statement will be similar to this. Okay, so you write if over a particular range, say any range you specify, say -5 x to 0, during this portion the value of the function is 2x, straight line, then comma this. So this is one function, this is the range over which the function is 2x. Then in the next interval, that is starting from 0 to, if x lies between 0 to 2, the value of the function is x square, and this is the second one, and the third range is between 2x to say 5. The function is cosine x. Got the point? This should be the syntax of that. How logical it is. So for a single function, if you want to clip over this range, what your range of interest is between -2 to +4, you are interested to know sin x, so only sketch that. And here it is a piecewise function, that between this range it is 2x, one function fx, between 0 to 2 it is another function x square, and between this range it is another function. And this function could be any function. For example, in general it will be either fx, this function could be gx, okay, or and this function could be hx. You have got the idea, I am sure. I'm sorry, I will push it up a bit so you understand. And this is hx. Clear? So this is how we will carry out this now. So I go to Geogebra now and try to sketch a piecewise function. For example, the function which I have written in the paper. So here you see that you go to your GeoGebra window and type it like this, that is minus 5 if the range, that is minus 5 is the range, then less than 0, the value of the function is suppose 2x, then comma, the next range starts, which is 0 to 2. I defined it as x square, so 0, x lies in this interval 2, and the function is x squared, is not, and then comma, the third one was from 2x to 5. I told comma, then cosine x. Let us see. Yes, it has drawn like that. If you just scale it down a bit. Okay. See, between minus 5 to 0, it is 2x, this straight line portion. Between 0 to 2, it was x square. 0 to 2, it is x square. You do it like this. And then between 2 to 5, that is 2 to 5, it is cosine x. Clear? If you just want to increase the range of cosine x, then it will just for so this, you go to edit, setting, here you type cosine x, this range you increase a bit, say you make it 10, 2 to 10, and okay, if you do it, so this is the cosine function between these two. So it was piecewise function between this range, the equation, that is fx is 2x, between this to this it is x squared, and then from this 2 to 10 it is cosine x. So how simple it is not? Okay, now I will try to sketch another, I will just hide this, and I will write another function which is exponential function. Very interesting. Exponential function is e to the power x in general. Okay, so I will first try to write, I do not know whether it takes like that, e to the power, e takes the value of e, so exponential e to the power, I say x, suppose I simply write here e to the power x. Now this function at x equal to 0, the value of the function is 1, and as x becoming more, the increase in the function is exponential, very sharp increase here, and when x becomes negative, its values decays and comes out to be 0. Clear? Similarly, you can just sketch e to the power minus x, for example, exponentially decaying function minus x. How it will look like? I'm so sorry, there is typographical error. E to the power, you delete this. So you write e to the power e to the power minus x, you write. And this function will be this red color thing. It also, in default it has selected this red color, it will be this function. Okay. Now as we have learned, so you separate this gx. I want to tell something more about this function. E to the power minus x is this function, exponentially decaying function. And in our physical system, this function often comes in your mechanics or electrical circuit, RLC circuit, this exponential function is very important. Anyway, so here what I want to say, I want to suppose sketch the function over the range for x greater than 0. I want to sketch. Okay, then I will say that this is there. Here I will write if you now know the syntax, x greater than, if x greater than 0, then the function is e to the power minus of x. Okay, you hide this and you get this function. So the object generated is this exponentially decaying function. And one must understand that you can make it less than equal to, greater than equal to, simply by doing this. You go to this and suppose you are interested to, if x greater than 0, instead of that, if x is greater than equal to 0, so you can just press equal to here, and it now shows that at x equal to c, x greater than equal to 0, all things are possible. Then greater than followed by equal to sign, less than followed by equal to sign. Also that point at 0 will be inclusive in this curve. Got the point? Therefore exponential curves are once again important, and they can be of course plotted the usual way other functions has been plotted. But one interesting thing I would like to tell, see, other functions are still present, but I have made them absent in the screen here. I have deselected them. Only this function has been selected, it is showing like this. Now what I will do, you see, this function is still there. I will make another function, which is, suppose I say that e to the power minus x, and this is multiplied by sin x. Then your thing will be like this, but you make it over a range, so you rewrite this. I am rewriting. If x is greater than equal to 0, then the function is e raised to the power minus x, e raised to the power minus x, and into sine of x. If you sketch it, it will be, this function will be the result. Clear? Therefore, product of two functions can be also sketched in the usual manner. Okay, and suppose you edit it a bit, you can play with the the coefficient of e to the power minus x. For example, e to the power minus of say 0.5x, suppose you do like this is called time constant of the circuit, and make it further smaller, then you get interesting waveforms. For example, e to the power 0.2x. Got the point? How I am editing it? Okay, and it will be like this. You can push this side, and you see the sine wave amplitude becomes lesser and lesser in every cycle, and eventually it comes to 0, because as you can see x tends to infinity, this term will vanish and nothing will be there. Very interesting plot, and these are very much used in this one. What you can do is this, once again I go to editing mode, okay, and go to setting. I try to do here, instead of 0.2x I will put a number here, a. Let us see what it does. If you do like that, create a slider, it automatically asks. I tell yes, you create a slider as expected, because I have written e to the power minus x sin x, and a can be varied. It has created a slider, and it will demonstrate in a much better way what is the impact of variation of a on the product of e to the power minus x into sin x. For example, you can easily see if x is less like this, if x is becomes negative, I will make what I will make. I will don't allow x to go negative value, only for positive value I want to do. So a2 I will only make it only positive. If you do, you go to the slider and make it say 0 to say this maximum value, you suppose say to 20, I mean just like that. Okay, and let us see what happens if you vary a. Understood. So product of two functions can be easily plotted, and various nice patterns can be generated if you wish. So this is the thing I wanted to tell you. Therefore, in this lecture, what we have learned is very important thing. One is about how to draw a function over a particular range, because you may often want to examine not the whole range of x, how the function is behaving, but over a particular range. So only sketch the function over that range. Similarly, you can have different functions over different ranges, and still you will get different values. So thank you for watching this, and we will continue our lecture next time with other interesting thing. Hope you have enjoyed this and learned something. Thank you so much.